Hi, my name is Jadana, and today I'll be talking to you about energy. But what will I be talking about exactly? I'll be talking about what is energy, kinetic energy, potential energy, and work kinetic energy theorem. Let's start off with what is energy. Energy is the ability to do work. Energy cannot be destroyed or created, but it can be transformed. Energy has two kinds, kinetic and potential energy, and its SI unit is in joules J. Now let's directly talk about kinetic energy. Kinetic energy of an object is the energy that possesses due to its motion. The equation for finding kinetic energy is half mv squared. M stands for mass in kilograms, and v stands for velocity in meters per second. Its SI unit is J-joule. Kinetic energy depends on mass and velocity. If mass or velocity increases, kinetic energy increases, and vice versa. But the speed affects more because it's squared, as we can see in the equation above. An example of a kinetic energy is a person walking. Now let's solve a quick question about kinetic energy. Find the kinetic energy of a 50-kilogram person walking with a speed of 9 meters per second. From this question, we can know that the mass is 50 kilograms, velocity is 9 meters per second. Now we already know the kinetic energy's equation, which is half mv squared. We already have mass and velocity. All we need to do now is replace them. So simply replace the numbers. So it will be equal to half 50 multiplied 9 squared, which will give us 2025 joules. So the kinetic energy of this person is 2025 joules. Now let's talk about potential energy. Potential energy is energy due to the object's position or energy that is stored in an object. Two types of potential energy are gravitational potential energy and elastic potential energy. Gravitational potential energy is energy due to object's gravity, and the elastic potential energy is stored energy in an elastic object after applying force to it. The equation for the gravitational potential energy is PEG equal mgh. M stands for mass, G stands for gravity, and h stands for height. The equation for the elastic potential energy is PEE equal half kx squared, k being the spin constant, and x being the distance stretched or compressed. Now, if we double the spin constant, the elastic potential energy doubles. However, if we double the distance, the potential energy quadruples because distance is squared. Now let's have a quick question about potential energy. A ball is raised 21 centimeters above a table. If the ball and its contents have a mass of 30 kilograms, what is its gravitational potential energy? This question is clearly asking about gravitational potential energy, which means we must have gravity, mass, and height. Looking back at this question, we will assume that the gravity is 9.81, and we already have the height and the mass, but they're not in the right measurements. So we're going to have to convert them. So for the mass, 30 grams will equal to 0.0 kilograms, and for the height, 21 centimeters would be equal to 0.21. Now, after we found the actual measurements, we are going to replace them in the given equation. So PEG will equal to 0.03 multiplied 9.81 multiplied 0.21. So the gravitational potential energy for this ball will be equal to 0.062 joules. And lastly, let's talk about the work kinetic energy theorem, which states that the net work done by the force on the object equals the changes in its kinetic energy. And by that base of information, we can understand the equation delta kinetic energy equal W net. Now, we will simplify this equation by expanding the kinetic energy, which will give us kinetic energy final minus kinetic energy initial equal work net. Now, we already know the equation for kinetic energy and the equation for the work. So we're going to simply write down each equation for each one. And in the end, the work kinetic energy theorem's equation will be half mass times velocity final squared minus half mass times velocity initial squared equal force multiplied distance cosine theta. And that's all about this lesson. I hope you learned something from it, and thank you for listening to me.